Hi, my name is Tom Kaler, and I am the co-founder and chief scientist of CrowdSmart. This presentation is a quick overview of applying uh, the new generation of CrowdSmart, something we're calling CS 2.0, which involves a completely new architecture for generative collective intelligence. However, I will be presenting here also the results of the initial CrowdSmart system, which was initially developed as a funding startup investment funding platform with a community of about 2,500 people. We learned a lot from that experiment, which ran from 2016 to 2020. And what we did is use all of that learning and some subsequent learning to build this entirely comprehensive new platform targeted at making forecasting accurately the outcomes of decisions that matter. The platform is set up to integrate both human reasoning with inputs from AI agents. And that's what is radically different from what was done previously. Our previous platform was done prior to development of LLM technology in its fullness, although we did use transformer technology as a way to model uh, how dialogue happens within a group. So what this is about is really just going over what worked and then what we're building on going forward, and then it'll move into a demo. So here is basically what we are talking about when we're saying generative collective intelligence. It is a way to bring humans and AI reasoning together in a guided deliberative discussion that would lead to conclusive predictions that systematically outperform any individual expert or any single AI model. So this, what makes it different is the collective nature. This is about a layer above everything else going on. And how do we integrate agentic AI with human reasoning? And we believe there are some key things to this. One of the things that comes out of collective intelligence as a science is cognitive diversity reduces error. And what that means is people looking at a problem from different perspectives that will be more accurate in terms of predicting a future outcome. This is one of the principles we adhere to within the system, kind of fundamentally. The second part of it is the Bayesian learning. It's constantly adaptively learning as the group is under the direction of the deliberation conductor. Think of the deliberation conductor as an orchestrator of the reasoning of people together with AI agents. So it's like your super facilitator that is trying to learn from the group what's important to the group. And this is literally a new adaptive learning AI model, but by the way, is very energetically efficient and has its roots in some neuroscience models of intelligence. So how does it work? Well, basically, for investing, you simply, or for any larger decision, you assemble the group of people that are subject matter experts. This is not, our name has crowd in it, but this is about the a group of people that know something about this topic, and they've been balanced a bit to make sure we have different perspectives. So if you're making an investment decision, have you considered investors, technologists, people familiar with the market, and users? These are all what would typically be done in evaluating investment. And then we bring those group of people into what we call a jam or a session. But think of this as a co-creative process orchestrated by the deliberation conductor. And then the role of that conductor is to aggregate and build a knowledge model, which is generative, which can be used to say not only about this particular investment, but investments of like kind. So the investment decision problem is a big one. And it, by the way, goes across innovation and startup investing. And normally, everyone, this is sort of a general rule, is that we consider a 10% success rate is okay in startup investing, or even new inventions or innovations within an organization. But only 7% drive all the returns. One of the things to consider, particularly when you're looking at creating an ecosystem that is going to do things like job creation and so on, is look for what we may want to find is a way that we're making investments that are sustainable and will eventually grow. We're not necessarily going for that one unicorn that's going to save the rest of the fund. We're looking for more of an equal distribution of return because this is going to create the greatest benefit in terms of things like economic renewal and wealth distribution and job creation. So the key elements here then are cognitive diversity, what we call Bayesian aggregation. What this means, it's also there's a adaptive learning process. And just think of this simple rule. I think I know. Here's new evidence. Do I change my idea based on the new evidence? That's simply it. I have a belief which predicts my response or what I think about a startup or whatever, and then I am exposed to evidence of what other people are thinking about. What are they applying to this investment? And then I'm learning from that. The director is learning from these various points of view. And then it creates explainable predictions. Now let's look a little bit about what actually happened. And by the way, if you look here, that what we learned from the entire experiment, where we looked at on the order of 70 to 100 companies, invested in 25, scored them, and then if they had a score above a certain level, we would invest a small amount of money, $100,000. And then we would also lead as SPV round into that startup, which was typically they're raising their first $1 million. So that's the background. Now, what we learned is that while we looked at four different attributes, the business, the investor quality, or investor, really what we were looking for is network. Were they able to provide a network effect? And then conviction, likelihood to invest. It has to do with deal terms or fitting to the fund or to the individuals. And then most of these were angel investors, by the way, and then team quality. And as you might guess, team quality was the dominant correlation. These are just the R is just the correlation between this and the ground truth results. Now, by the way we got ground truth is we would invest and then we would look for a follow-on round. And from that follow-on round, we would then, kind of give it okay, that is a success. In other words, it knows how to bring in more money. That isn't the measure for long-term success, but it is a very useful near-term breadcrumb, so to speak, of indicating survival rates, because a survival rate is an absolute necessary condition to get a return on investment. Now, what we're able to prove, even with this first generation model, is that we have and this is as of about a few weeks ago, this is 8 years later, post-COVID. A lot of things happened in these last 8 years since sort of the center point of that period of 2016 to 2020. 71% of the portfolio has survived. And that's about 1.9x of the industry average, and that's taking from Carta. Now, again, this is not meant to be scientifically validated with a control and experiment, but it's a very, very, very strong indicator that there's something here. And so the point of this presentation is now with the new architecture, how do we leverage that and accelerate it? Again, remember that this was pre-agentic, pre-LLM. Now, we're going to look at a particular company, obviously one of the higher scoring companies. This did turn out to be a unicorn. This looks like they're going to be able to go public next year. They're currently edging on about $1 billion valuation off of when we evaluated in 2017. they were raising their first 6 million in a convertible debt. And that's what we participated in that early stage. So now what we're going to do is flip over to actually looking at the system itself. And what I'm going to show you here is what we are now calling the research platform, meaning this is the full bore of all the system can do. Do not necessarily interpret this as the UI for what we would do based on investment. One of the things we need to do for scaling is make this extremely easy to use. And we have a product aimed at that coming out in beta shortly. And we will be ready to demonstrate that to you very shortly. But it basically takes a lot of these things and just makes it easier to navigate. But this is actually a back end of this is a full API. So part of our business strategy is not only to have a vertical application class, but also be able to tokenize and offer a lot of the techniques here, which have broad implication to other licensing situations. Now, the thing that we're using the term jazz for this, jam for this, because of, in essence, a lot of times when we're doing investment discussions, it's a little bit like jazz. One person's mistake may lead to somebody else's greater solo or idea. And so we just want to create that sense of you really want to be listening to each other and trying to learn from each other in this. And what are we learning from? The views of other investors. We don't see their scores, but we see their reasoning and their thinking. And in the future, we can even bring in AI agents to help that. The current platform will support that. The data I'm going to show you was human only. This was done, frankly, the data I'll show you was initially gathered in 2017 and repurposed into this environment. But that data, we can look at every detail of what people were thinking when they made that investment decision. This is something very important. We don't do well of going back and recalling what were we thinking when we made a great hit or we made a great mistake. The point of this system is you can record all that. Now, the jams can be divided into categories, and I'm going to only show you early stage investing, but this can be used for economic forecasting, key decisions that matter, like the approval of a drug for a pharmaceutical company, or it may be looking at and we've used it for this purpose, forecasting the future of a market like commercial real estate after the COVID pandemic. So there's an ability then to have these jams and what is the purpose of a jam? It's just thinking together and forecasting what we believe is a future outcome. So this is kernel to a very frequent process. A lot of our work is getting together as teams and trying to decide how do we move a project forward. Any decision of that level where there's a need to learn from each other is where this applies. And in particular, what we found in the investing case, people wanted to learn from each other. So what you see here are actually some of the companies from that first period. There were, as I mentioned, there were 25 invested in here. We're just showing four. Um, and we're going to look in particular at Syntian, but we also, Donut Media ended up selling, and Air is still going at actually doing rather well. And so is Stabilitas. So we can essentially look at that portfolio in detail, but right now this is just gives you a sense of what's going on there. Now, the second thing we want to look at is when we click on Syntian, what we'll see, this is the circle of people who were involved in the investment. Identities masked, and those lines in the middle are they're peer reviewing each other's information. That's just to give you a visual of the fact that all of the learning here is out of the interactions. And nowhere else is this being captured in the way it's being captured in this platform. We learn from each other in investing. So this is not so much what does the data say. That's good. That can be brought in by agents. But what do my colleagues, and so think of any case where you have a group that needs to all agree on an investment. And this is often case for investment decisions, you have a committee or a group that needs to agree. This enables you to navigate that process. And then you have something here called idea jam. I may want to just first go in and look at what are people saying. What are people saying about this investment? And these symbols here mean I can ask them a question. If it's an AI agent, it will answer. This case, there's no AI agents, but I can ask them a question or I can build on one of their ideas. So I can just treat this as kind of a Reddit style discussion group at this level. But then when I click on join the conversation, I go into something that looks like this. And this is where we will be upgrading the UI, but the individual participant is just now moving into kind of a directed thinking mode. It's think of you're being prompt engineered by the AI in some ways. Do you believe sentient is a highly compelling business opportunity? And you just do a slider of, what your estimate is, what your thought is around the business itself. This is only looking at the business factor. And then you give your reasoning. And when you give your reasoning, that is going to go into a language model, that private language model about this deliberation. This is what the deliberation conductor takes your idea, installs it in a model, and then thinks, what are some ideas that might be stimulating to this individual? Now, here, I'm not going to go show you me typing in, but I am given when I just say I want a peer review, I'm giving a list of 7 of what other people have said, and I can indicate I agree, disagree, need more information. If I say I agree, I want to know why. Everything we're about here is what's the why? What's the why? Because we want to discover what caused you to make a prediction. The human brain thinks in cause and effect. AI thinks in pattern recognition. So these are great complements. Now, when I do click on that, it goes into a priority list, indicating the first thing I clicked on. Then I get a chance to adjust the priorities. That's it. This is all that's required of the individual. Now, when they submit this, the system memory is updated so that the deliberation, the deliberation conductor is able to see and learn with the group what's important to the group. So it's constantly learning and using that learning to interact with the next person. Now, all of that together results in a private language model. Here, I have typed in the question. This is called query the collective voice. We now have a model of the collective mind about this outcome. And so I can ask a question. What are the reasons you consider compelling? What do you consider as compelling reasons to invest? And here it gives it. Number 1 is the market opportunity. Number 2 is a strong team. Number 3, you get the sense of this is now, and this is not going out to an outside language model. This is purely developed from what we've learned from the interactions of the group discussing this investment. And what's even more important here, I get citations. So this is very different from the way these models, we're using transformer models, but these models have highly provenance data. We know the context, we know everything about it. So we're using the language learning technology in a very intelligent way to just be able to create what does a group understand? How does a group work together and think about this? So you can look at the specific items and who, if we want, we can unmask the identity at this point and say who said it, but or not. Either you have a choice of doing it either way. Now, there's much more to this because if you go down, we can see the relevance of each comment to the group. So high probability to low. You can see the scoring patterns. You can see, in this particular case, we're just showing the detail scoring patterns. And we also can compute. Now we've learned what causes you to write that answer. And here we're able to compute a Bayesian belief network. And that's a knowledge model of what everyone is thinking. At the center is the score that the group is now applying. 89% It turns out the score was actually 93. This is repurposing a little data. And I can look at how we scored on each of the attributes. I can also look at what are the dominant themes driving, and it's learning thematic reasoning that is coming from the group as it goes along. And then I can actually see the individual inputs on the outer rim. And I can continue to go down. There's all kinds of mathematical analysis. This is really saying how does the group's uncertainty get resolved over time? This is something called the free energy of the group. As the group is coming to alignment, and just think about it, it is really like a free energy. We're coming to agreement. There's reduced energy and tension in the group. This is actually a real thing that can be measured. It has to do with, we now know how people are relating to each other's ideas. So we can actually calculate that free energy. Now, these are all the details which you can look at on the analytics if we want. And then here is something else. We are able to look at the semantic similarity of different things. We can go into the detail. I don't want to bore you with that, but just know this is all constructed as the dialogue is going on, as this is what the deliberation conductor is doing. It's very busy. If you think about a human facilitator, they're trying to write everything down or whatever. Just think of an AI that's doing that. It's basically keeping track of everything and then building out all kinds of analytic and display models of how things work. So it can look at what's the potential for co-creation. So you can see that there are some clusters here. Maybe these ideas are possible ideas that might create serendipity or some new discovery. How did things evolve over time? What are the causal relationships that might be coming out of this that link reasoning? And you'll find if you dig into this, we don't have time for this demo, you'll find a very clear, begin to look at, this is a big market, this is a great team, they have some differentiated technology, and you start to get a real understanding in depth of what is being learned. And then before we finish up, this gives you a quick overview. Happy to discuss more. Before we finish up, let's look at this. The system is now also fully agentic. Now, thinking currently, what we couldn't do back in 2017, we can now bring in various types of agents. So this platform supports knowledge agents. What are knowledge agents? They're unique stores of information. They're private. They only reason from the documents or data you give them. So for example, I can dig down here and look at, here's a knowledge agent on investing with CrowdSmart and generative collective intelligence. I can just simply, by the way, it has analytics, so I can look at what are all the queries that have been asked of it so far and what it's been its response rate and all that. But I can also um, get this out of the way, go in here and ask it a query. So I could say, uh, just basically ask questions about other investing things that have happened with this platform. I'm not going to go into this here, but you get an idea. Now, these knowledge agents can also be invited to a deliberation. So you can now take a lot of data, say about a company or a category, put that into a knowledge agent and invite it to the party to reason with the investment group. So now you see an integration of the ability to integrate large quantities of data, which humans are not very good at, with judgment and sort of that magic or that ability to see ahead. That comes from within the humans. Humans have about, if you look at it, even if you take the largest large language model, human have about that, it really represents about 1% of the human brain capacity right now in terms of just counting synapses, et cetera. I mean, just looking at the complexity of the network of the brain versus the most comprehensive neural networks. So The human brain could be anywhere from 100 to 1,000 times more powerful at intuiting what these outcomes might be. So that's basically all I wanted to present is to give you this overview. And we can go back to the presentation here and say, well, we learned that with sentient, there was they created a new category. Here we see what are the basic breakouts of other companies in the portfolio, and this is where we got the 71%. So with this now, we think we can take what was a pretty good success then, but really create a powerful a very powerful way forward. I'm not going to go into any of the details of the technology, but there's a very deep and robust new kind of architecture here that also has an API front end. This is a this is like a next generation AI. It isn't, and by the way, everything I showed you is running on something right now as $100 a month, something on that. So it's not we're not spending $100 million to train a model. This is extremely energy efficient because it's based on principles like the brain operates. And the brain operates at 15 to 20 watts, not 75 gigawatt hours or whatever it takes like to train a model. It's about the amount of power needed for a community of 100,000 people for a month. Uh, that's not that's not energy efficient. This is. Now, so that's basically the overview. We think this is the opportunity is now. This is and there I am seeing an increasing amount of discussion. How do we bring all the knowledge together? That's what this does. You need a deliberation conductor. So the buyer, if we take this beyond just investing, it can start off with uh, uh, group community investment groups, et cetera, but then they could go into head of corporate development, chief strategy officer, CFO, CIO, into consulting groups. So there is a large market opportunity here where we can take forward a very new kind of technology that will uh, create a new way of us thinking about how we innovate. Thank you very much.